This is Open Research Institute's projects meetup for the 4th of November. And what we do is we talk about what we've done and what we have planned to do. If we have any roadblocks in our way, and if we need any resources that the nonprofit can provide. And we have plenty to talk about. What I'll do is I'll hand it over to Matthew because he's got lots to report. There's been tons going on with the modem. And go ahead, you have the floor.
All right, very good. Thank you. Good morning, everybody. So I had updated, I think mentioned last week, the peak RDL definitions. We completed the clock domain crossing improvements for the status registers and the configuration registers. So the status registers and the configuration registers exist in the AXI clock domain. And so then those come out and then they need to move into the modem clock domain. Generally it's not a problem, but it can be a problem in that you can on occasion have a metastable event when those clock domains are not aligned or they're asynchronous. Just for reference, it can be a problem even if your clock domains are synchronous if they have an undefined phase offset. And so that phase offset could create a situation where the clock edges are aligned in such a way that you still enter these metastable events. So it can even occur in synchronous clock domains. But where the phase offset is not known a priori. Anyway, so I was improving that and kind of combined that with a move to peak RDL from the previous DESE RDL VHDL exporter. And so we had an interesting issue. What I had done is using peak RDL, they implement more of the system RDL constructs, what are called properties for the fields or registers. And one of the things you can do is declare certain registers to be external. And when you create them or when you declare them to be external, there's no register existing within the RDL VHDL output. The register exists somewhere else in the domain, in the design, which was the case for us. And so when you declare it as external, the DESE RDL creates a request signal that goes out to the hardware, and then an ACK signal that comes back in that is coincident with the read data. So when you send out the request, we were resynchronizing it to the modem domain, capturing the read data, the status data that we want, and then we would resync the request signal back into the AXI domain as an acknowledgement, and you would already guarantee that the data was captured and stable when the acknowledgement came back to the AXI clock domain, and we should have been able to capture the data without any concerns, or the clock domain crossings have been taken care of, addressed. What we saw when we built the hardware and put it in the lab, well, first in the simulation, it worked great. So the idea here, what's nice about it is I can just send a normal AXI read to capture, to read that status data. The hardware takes care of all the resynchronization and would normally insert wait states on the AXI bus in order for that resynchronization out to the modem clock and then back into the AXI clock. And it worked fine. It worked great in simulation. So I just do a read and we get the data back. But when we built it in hardware and put it in the lab, the Pluto was very unhappy. And after a lot of discussion, I think we kind of came to the conclusion that it was likely that that for some reason the AXI bus was unhappy with the wait states. I don't know that that's the root cause, but that was a working theory. And what we did is we commented out all the external registers just so we could see if we could, it was a quick change to comment them out. We rebuilt and just saw that the Pluto didn't crash anymore or go into these reboot loops, but we were still able to read back the AA's 55 registers indicating that the AXI transfers were working correctly. So we've surmised that there was some unhappiness with the AXI bus with the inserted wait states. The exact root cause has not been determined. And so, that's something maybe for some future debug work, which be good to resolve that, understand what the issue is, and if we need to do a pull request for upstream, that would be a good contribution to the peak RDL project. But in the meantime, we know what the problem was. So I've been going back and updating the peak RDL, and instead of using these external register declarations, they're all internal. And what, in normally or often what's done when you have these clock domain crossings with the registers is you'll have a register that you dedicate as a capture register. So you write to that register, and that write goes out and is effectively a request. It goes into the modem domain, captures data into a register, and then that register is stable. And then I can come back and read that data register, and again, not have any issues about clock domain crossing, because that output register is stable, and we're not going to read it until it's stable, because we do the write first and then do the read, and there's enough time between the write and the read that the read data is stable across that clock domain crossing. In order to not add more registers to the design, what I've done, and I have it in simulation and working, so I'm about to do a push on the new branch, or on the peak RDL branch that has this new mechanism. The idea here now is we write to the register that we are going to read from. And so instead of creating a new register that we write to, we're going to write to the register that we want to read from. When we do that write, the peak RDL VHDL generation puts out a software mod signal saying that the software has modified that register because we've written to it. We use that software mod signal as, again, kind of a request signal, and it goes out and captures the data, and then that data is stable when we do a subsequent read. So first we'll write to the register we want to read, and then we read from the register we want to read. And the data will come back, and we don't have any clock domain crossing issues. So that is implemented. It's working in simulation. No wait states are added on the AXI bus, no external registers. So we have no reason to believe that there's any, that we would have any issues with the reboot loops, because we've removed that external register declaration that seemed to be causing the problem previously. So we have an approach here to be able to read the FIFO pointers, read and write pointers, and the other data that's important, like the loop filter accumulators and the loop filter error values that we want to read back to just get general status from the design, the AXI count, transfer count counter. So all those counters now are clock domain crossing safe. They weren't previously, so occasionally you might get a value that's kind of weird, and that would have been due to a metastable condition. I'm not sure we saw it very often, but it was certainly a possibility. But now we shouldn't have any concerns about that data being invalid or having a metastable condition flip a bit. So I think hopefully we have this resolved, and it was unfortunate to go through that little difficulty, but it's good. It's a good learning experience, and getting familiar with the peak RDL tool. I think the industry, commercially is moving to RDL descriptions. It's a much better way and easier way to manage configuration status registers. If you have big ASICs, there could be thousands and thousands of configuration and status registers. So it's a very powerful tool in the arsenal. So I think it's good from our educational mission to be using RDL and, getting an understanding of what works and then, contributing back to these projects if we find issues like we're finding here with the external registers. So that was the fun for the week. Didn't have anything else that I worked on or to report on.
Yeah, that was a lot. And yeah, wow, you stated it so very well. When we say RDL, it's registered descriptive language, and it's similar to like hardware descriptive language. So what we do when we do all this FPGA work is we describe what we want to see in hardware. We express this in a way that is in a software context, and then we have tools that turn our description, hey, I want hardware that does this or that, and we turn it into either an FPGA or an ASIC implementation, like actual hardware. So the management of the registers, and when we say like CSR, we mean control and status registers. These are registers that like configure, choose, you know, control the hardware. Since we have lots of levers that we can wiggle around, and we need to know information back from the system, like, whoa, what's your SNR, what's going on out there. So the configuration part is the writing to the design, and the status is the reporting back. Some registers do both, some do one or the other. And managing this is usually, or in the past, has been like, oh, just manage it. It's just another part of the design. The whole RDL thing, the registered descriptive language, formalizes this and lets us like have a mostly or partly or totally uh, automated system that if you tag things in your design that are registers, then it goes out and collects all of those parts of the design and then presents it back to us as, well, here's your status registers, here's your CSRs. And the huge win, at least from my point of view, is that I don't have to maintain a header file manually of all the registers, which was even with our design, which, okay, so we only have, a couple of dozen registers, right? So that's still a lot. And anything that can help this, and like Matthew says, a big ASIC can have literally hundreds of these registers. So some sort of formalized way of managing them is good. We had a okay way of doing it, but it was very flat and maybe not as hip as we could be. So this transition from one framework to peak RDL is really good. The peak RDL, it's a pretty obvious win because it actually has a hierarchical sort of access and a lot of other advantages. So just in the broader context of like, is this making our life easier? Well, in the short term, we had some issues where it bricked our Pluto or crashed the Pluto, and that was interesting. And I'm really sure that the peak RDL people do not want this to be the experience. And if there is something we missed, or if something that needs to be brought out more in their documentation or whatever, that they're going to really want to know about it. So I think we should absolutely talk to them and let them know what happened. Um, but we fixed it, I think. I mean, the build that we recently made on the debug branch from Peak RDL didn't derail the Pluto. So the things that you've described today have resolved, at least on our end, how to move forward. And but I mean, if I was a peak RDL person, I would really want to hear about what happened to us. So somebody really should probably reach out at this point if we can like coherently explain like
Well, what I'd
yeah.
like to do, yeah, but it's going to take some time, and I don't have my lab set up right now to look at this. But ideally, I'd want to put a serial monitor on and see what's going on during the boot process. But then even further, put an ILA into the FPGA, and actually, if we put the processors in a debug mode, we should be able to single step the processors, or at least break on the AXI transfers, and then capture what's happening on the bus and see if we can see, exactly what the error is, what's happening on the AXI bus that's making the processor unhappy. And in doing so, then we can, more, we can well state what the issue is. We can fix what we think the issue is in peak RDL, and then, even submit a pull request to resolve the issue.
That'd be great if we could do that. I think probably, I think what you're saying is like keep it in mind, like keep it on the kind of on the front burner and try to figure it out and document it moving forward. Um, and we're not entirely sure like what was the issue.
Right.
Okay, that sounds totally fair. Let's try to keep it in mind and be of service to this other really amazing project because we know we know how hard it can be to figure this crap out. So yeah, thank you so much, Matthew. This has been great. I think it was a good call to go ahead and transition from the DESE RDL to the Peak RDL when we needed these new registers. And I have a little bit of an update on why we needed these new registers. It's because when we go from streaming to framing, that it works great in sim. It works great on my computer. It looks gorgeous in simulation, but it absolutely falls down flat, like tripping a linebacker in a game, in hardware. And Paul has done some really good work here in figuring out like, okay, when we go to set up our framed system, which is essentially almost all of the opulent voice, minus some stuff that has to be done in software, but we have actual frames, and it does only a few. Actually does transmit. We can see it on the spectrum analyzer and then times out. So the FIFO, probably one of the FIFOs is at fault here. So I have a little bit of progress here. There is a bug that could possibly explain what we were seeing, and that bug has now been fixed as of late last night. So what was going on was indeed an initialization bug. When we roll through in simulation, we would see that the first frame would lock, no problem. It would find the synchronization word, the marker for the first of the frame. It would decode the rest of the frame, present it to the as an AXI transfer, and then the next time would totally miss the sync word off by a byte. Now, fine, it would go back to hunting, which is like, oh, if I don't know anything, I'm going to hunt. Then it would find another sync word, and then everything after that was fine. So, what does this kind of mean? If you've done any of this sort of work for any amount of time, you go, oh, and it's an initialization bug. You haven't initialized things correctly. Your first frame is off. Of course, the second frame will fall down. That's where it will show up. And then every other frame after that is fine. I'm an embarrassing number of hours blaming the test bench for failing to give us good frames from the get-go, and it was exonerated multiple times. And then going and also improved because, anytime you look at something, you're improving it. I went through every module that we have until I finally got to the one that of course was not a problem, which was the DMA adapter. And guess what? In idle mode, it says it's ready for data, but it's really not. And that's the missing byte on the first byte of the first frame is just gone because it's in idle mode, but it's still asserting it's ready. And it just silently ate that byte. And there was just enough of a runty little bit of a byte. And the only reason that you would notice this is if you made an interesting pattern on the first part of the frame so that you could compare it. Because I'm thinking it dropped off the back, which is what usually happens. So lots of lessons learned here, probably a whole story. But guess what? Bug's gone. Now, I assumed that this was related to the missing TLAST signal that we have when we get all the way back through the receiver and we send the frame back to the processor side. Well, guess what? TLAST is still missing. TLAST is still glued on to the next frame. So there's some other problem with counting. And it looks pretty clear that it's actually in the sync detect. And it's counting out 269 bytes instead of 268. So that's the next thing that will get attacked. Lots of other really small bugs in this bug hunt were found. which is how it usually goes. So you get down into the intestines and you start yanking around and looking at things, and you find all sorts of other stuff that was kind of shortcutted or maybe not great. So we've cleaned up a lot of stuff in this process. It wasn't just multiple days wasted on what turned out to, yes, be an initialization bug. It's going to make our design even better in the long run. So that's what happened over the past week. That was a really good thing to finally find because you can start thinking that maybe you're a little bit nuts looking at results on a sim that are essentially your entire synchronization is thrown loose and has to rehunt and refine things at the bit by bit level. That's never really a good feeling. So that's the good news. That's in the sync detect branch. And until I can get the TLAST, which is this is a signal in the AXI transfer protocol that tells the consumer, which would be Paul's code in Dialogus. We're sending essentially the receiver is sending an entire frame processed. Here's the frame. We stripped off the sync word. Here we are. Here you go. But I have to tell you what the last byte is, or I have to tell the DMA controller what the last byte is so that the receive buffer can actually get a coherent frame. And that is not happening correctly. That may be the reason that the entire thing is kind of timing out. The timeouts to me in libeIIO are a little confusing still. I've learned an awful lot over the past couple of weeks, but that's the status on that. I think we're super duper close to going from just a streaming protocol to proper frames with proper AXI behavior. Um, and that if we can fix the T-last thing, that may actually explain it. And if not, then it's probably something weird in hardware with the FIFO for the clock domain crossing or dual clock FIFO that we have is as yet undiscovered, conundrum, like Feynman said. And I think that sums up pretty much all I've been up to on Opulent Voice, and I'll defer to I'll hand the floor over to Paul because he was very much involved with all of this, and I think he has um, a lot from the Dialogus and maybe interlocutor perspective to report. So the floor is yours, Paul.
Thank you. Before I get started on what I've been up to, I wanted to ask Matthew a few questions about what he said. Um, um, Last time I knew anything about what you were planning on doing, it was going to be uh, a separate register that you'd write uh, to capture the data to all these registers that are crossing clock domains.
Right.
Um, so you switch to writing to that register and reading it back. That implies that none of those registers were already read write.
That's correct. The status registers were all read only up to this point. Now I've made them read write. So, and what happens is, yeah, I mean, you have to write something to it. What's right now in simulation, I'm just writing a zero. So the register actually clears out. And I'm hoping this isn't an issue in software, but in the simulation, I need to put in two clock delays before I read the next value. Otherwise, I read back the zero that I just wrote because the round trip delay hadn't completed yet. So if that makes sense. So basically, I'm writing in my simulation a zero to the register I want to read. If you look at the value of that register, it goes to zero, but then like a clock or two later, it goes back to the value that we're wanting to read. And then if you do a subsequent AXI read of the register, you get the value that you're looking for. The reads happen fast enough in simulation that I have to put two extra clocks in the read cycle to make sure that the data is valid. I'm hoping that, in software, there's enough time between back-to-back reads that we won't see that issue.
Probably true. I guess we'll find out. Is there something special about writing zero, or could I write some more recognizable pattern, and then if I read it back, I'll know exactly what happened?
Yeah, you could write anything.
Okay,
Yeah.
that's good.
Any write triggers the triggers the read back, or the capture of the data.
Yeah. So one thing you lose by doing this is that you don't get a consistent set of reads from all the registers in that region. If you had the old system that you were proposing a day or so ago would get you a snapshot of registers that were all consistent at the same instant.
No, we get that still. For instance, like if we look at the TX asynchronous FIFO pointers, right? Those pointers are read back into the same register. So when we write to that register that we want to read from, it sends out this software mod signal that goes to the async FIFO. And that software mod signal captures the read pointer and the write pointer at effectively the same time, except with the uncertainty of the clock domain crossings, right? And then it takes that captured read and write pointer and sends it back to that register. So that register is two fields. The low 16 bits is the write pointer, and the upper 16 bits is the read pointer. So we are capturing the read and write pointer simultaneously as close as we can, given the clock domain crossing uncertainty. And so even if we had more registers, say, that we wanted to capture, say, like, for example, like overflows or underflows, you could still read from the first register, and it could capture data from other registers as well. It's just because it's all in the hardware design. We can do whatever we want with that software mod signal. So if we had like 3 or 4 registers that we wanted to all capture at the same time, we would do the write to the first register that you would read, for example, and then it could capture the data for all 4 registers. And so you only need to do the write to capture once, and then for the first register, and then you'd read that, and then you could read the second, third, and fourth register, and the data would all be captured already.
But we'd have to anticipate that, at design time.
Yes.
Yeah. Okay.
But I mean, it's not much different than if I had a dedicated write to capture register, I'd have to write that one first and would capture the data for all 4 registers. Now I'm just kind of making the data register that we want to read, or if it's a group of registers, the first register that we want to read as the effectively writing to that register is the write to capture, instead of having a new register. We could do it either way. I'm not, one's not necessarily better than the other. One of the reasons I just did it this way is so that we're not adding more registers to the design, so that we have less of a software impact. I will say that I'm wanting to refactor all the registers going forward, but I want to coordinate that very closely with the software because it'll impact the header file. So I've been kind of working on that. So the idea here would be that I'd have a set of RDL descriptions for each submodule. So the PRBS submodule would have a set of RDL descriptions.
Oh yeah, that's good.
The modulator would have its own set of RDL descriptions, and it is good because the RDL, in part, it's not just a definition language to implement the hardware. It tells you something about the design. It's documentation, right? Source code is the ultimate documentation. And so the RDL becomes the documentation of the design. You could look at their RDL and know, if you look at the PRBS, for example, and you look at the RDL as part of the PRBS repository, it's telling you what the PRBS needs for configuration and status, right? In terms of what the hardware is implemented. And then what's neat with the system RDL or in the peak RDL is then at the top level, you can basically, when you compile the RDL, it grabs all the submodule RDL files and includes them in the top level RDL or VHDL output and the top level documentation output.
Right.
So it fits again with the modular approach that we're wanting to do. And but that's going to have a pretty big impact on the header file and on software. So as I'm using it more, getting a better feeling what the name should be. Some of the names are changing, trying to make more consistency between the register definitions and field definitions. So at some point when we're ready, we could pull that in. So I'm working on that refactoring now in a side branch, and then at some point when we're ready to pull that in, we can coordinate that and get the software updates that we to go with.
Yeah. No, that'll be really good. It was pretty obvious just from a casual, casual fly through for the peak RDL that the potential for enhancing kind of the explanation power was better than the previous framework for DESE RDL because it was flat. So like you have a bunch of registers, and I think that those of us that have worked in the industry a while know that that's kind of somewhat traditionally how it was done. You had a whole bunch of registers in a binder, and you had to kind of pick and sort, and some of them were important and some of them were not. But the peak RDL, the hierarchical way, and like it lends itself very directly and clearly to being allocated towards like, okay, this part of the design of this module. So the modem module thing matches up really well with the way that particular framework can happen.
Right.
So yeah,
And the other thing we can do is it might segment the address space a little bit more. Like the submodules could be allocated each, it's probably, this would be way overkill, but you could do like 1K address space or 512 address space or 128. But at least, and so then when you build the top level, the addresses aren't just all run together. The
right.
addresses then become segmented. And so this range of addresses is always the PRBS. This range of addresses is always the modulator, things like that. So it kind of, I think,
Yeah, this is like head and shoulders better than I think the traditional way of doing it. Like most people just list the CSRs and that's it. You're kind of on your own, and you have to kind of pick through or go through the source code to figure out what's what.
and that's part of it, but the other part is maintenance, right? Because then
Yeah,
if you need to go modify a register, it's in, go dig down and find the source code, and then there might, if you wanted like the work I'm doing now, where I switch to an external register, the rec request ACK protocol, or even this right to capture, if you wanted to make those changes and you had RTL descriptions of your CSRs, that would be a lot more work
yeah,
here, where the tool now is doing all that work for you in terms of generating the signals, updating the structs, everything that is part of those types of changes becomes really easy. I mean, RDL is certainly a descriptive language, right? It's an abstraction, right? And it's, in many ways, a domain specific language. And so I mean, it's like you have hardware implementation, but then RTL is an abstraction on that, or like, the base level schematics. RTL will describe an abstraction on the schematics, right? And then the RDL is kind of another abstraction on top of the RTL.
yeah.
Um,
Wow. Okay, that's huge. Yeah, thank you so much. This is really cool, and I think that we're moving in definitely the right direction. And yeah, I think we've done a huge amount of work here with a design that has some solid modular power and bringing the sort of the register map up to the same level, which is sort of what you're talking about when you say refactor. I think you mean to like make it functionally responsive to the design that, and there's probably a lot of really solid computer science theory here that we could talk about. Like this is sort of like oh yeah, okay, this is a whole area where we can just be smart about it and get it expressed and organized in a way that really steps is a huge step forward. So
right.
thank you so much for that. That makes total sense. And yeah, we'll just be standing by. The good news is that since it's already kind of abstracted, since we've already kind of decided to use RDL, and it's like no longer does Paul or I or whoever else wants to contribute, no longer do we have to like pick through documentation or source code to figure out how we talk to the registers. We have a header file. So we have a header file in the repo right now that you can use to talk to the design. If you just updated the header file, then that's just what happens. I think that maybe that's not what you're talking about when you say refactor. You mean like maybe consolidating, reorganizing what's actually in the registers, which yes would have some impact. But with a solid header file and a markdown and the descriptions that we already have, um, then that work is actually not horrible for the programmer. They have, we're talking about like automatically generated, um, files in some cases. Like this is all going to be presented to you. Here's the new organization, and this is now not hours and hours and hours of ugly work. It's actually like, okay, here's now the new register map, and you adapt. So I think that this is the best possible uh, thing that could happen. So thank you. I look forward to it. And yeah, I think we could probably compress our register map down. Some things that we needed at one point we might not need, or some things that are over here that probably should be consolidated with these things.
Yeah,
I know
it's
that we
kind of
have
a mishmash. We just add registers to the end
yeah.
and we new registers, but they're not necessarily grouped in a functional
Yeah.
manner, right? And so that's what I'm looking to do. And some place, we at one point we split the NCOs from the TX to the RX. But again, if you had the TX NCOs in the modulator RDL and the receive NCOs and the demodulator RDL, I mean, that's a better
Yeah. No, that
organization,
makes sense.
for example.
Yeah. I know there's some things that are scattered around, but
Yeah.
no, this is great. Thank you so much. I anything you need, let me know, and we'll just we're looking forward to seeing this folded back in, and then getting the header files and the documentation, and then striding forward. I think that'll be good.
Yeah. So just as an update, I just pushed the updates for this right to capture approach, so we could start a build as soon as we want.
Okay.
I will update the descriptions a little bit better, so it's not it's clear what I didn't update the documentation of the registers to say it's a right to capture type thing. So I need to do some cleanup on the register descriptions, but that shouldn't, I don't plan to make any changes to the functionality.
Okay, but what you want to know is whether or not the build functionally works in hardware. Like,
Yeah,
okay,
right.
yeah,
So
we could
yeah,
do that.
if we could build it, make sure we don't crash the Pluto
Right.
again, and that we could read back some of these status registers and get sane values, that would be a
Okay.
good step
So
forward.
so like read back the ones that we already know about, like the ID register, things like that.
Well, yeah, that would just tell us, yeah, the registers are there and we're able to access them. But even just start everything up and read back, do the write to capture on, say, the TX async FIFO pointers, and then read that back and say, maybe do that a couple of times and see that the pointers are
Right.
incrementing and doing what we would expect them to do.
Right. Okay. Yeah, I think we can move forward on that. I'll see what I can do today so that we get an answer fast. Yeah, thank you so much. This is so great.
I think this means it's now even more so than it already was. It's time for somebody, which might be me, but preferably be somebody who is more of a Linux kernel guy, to go read the IIO drivers for the Pluto or for the analog device and make sure that all the probes it's doing on startup are not going to cause a problem with this. Um, I don't
I
know what it's assuming about those registers, whether it can, maybe it expects to be able to write and read back some registers, or maybe
I
it's just trying to
I can
read.
I can add just a little bit from some hard-earned knowledge. The
Yeah.
the so when we boot the Pluto up, which is very similar to most of the other Zinc based SDRs that are in the analog devices and Xilinx universe, when they boot up, and whether you have build root or pedal Linux or whatever, if you have a Linux kernel, then what it's doing is first thing is or one of the first things is the bit file. And so bit file, and then it says, oh, look, device tree. So it does that in that order because, well, there's an awful lot of hardware out there potentially with this FPGA design in this hardware that you've described. And that has to come first, otherwise it'll crash. So here's the bit file, and then, oh, look, a device tree. And then it looks for things like overlays, modifications, because you have a whole device tree modular approach on the in that world. There's a lot of reasons for not modifying the device tree that comes from the hardware reference design. For instance, you want to keep that kind of pristine, and then you want to overlay your custom stuff. That's a choice. What we're doing is that we take the device tree from the reference design and we use it as is, but we are introducing our particular changes. And so our code, our MSK top, creates an entity out there that appears as part of the device tree. And the kernel then probes those registers and it says what's out there. And that could be the reason that we had these crashes, because there was some mismatch here in, well, you said you were here, but you're not actually giving me anything. So lock up. Now we're not seeing that anymore with some changes because things are becoming clearer, we're becoming more in line. So the whole order of operations is that these probes from libIO, and that's where they're from, are kind of aggressive. And they are this is sort of from the industrial input and output or IIoT background. It is going out there and it's finding out exactly what hardware is out there through the registers. So these probes, it kind of varies. It's kind of complicated, but just to sum it up, these probes aggressively happen very early in the boot process. And what they're designed to do is to bring back, like, okay, here's the landscape, Linux, go. And then the rest of the boot process happens. And so as long as we use libIO, and we do want to use this because it gives us lots of benefits, then we have to kind of respect the process that it's going to go interrogate the hardware pretty early on and do these probes. And they're like a function and they're documented, and I'll keep reading up and learning about it. But that's what's going on. And we're not going to be able to like stop it or postpone it or anything like that. And we don't want to, because, our stuff is actually showing up correctly. It's in there. And it will absolutely work as long as we kind of like go with the flow. So I hope that helps a little bit. That's the facts of the boot up process, kind of in the guts of the kernel.
Yeah, I've long believed just from symptoms that it had to be doing something like that. That's the only thing that explains, for instance, why rebooting the system changes things that aren't changed by just restarting the software. So I'm relieved to find out that the reality matches what I had inferred. We need to make sure that we change the registers. We don't change them in a way that bollocks up that system. Is all I'm saying.
Yeah, I think we've got it sorted out now. I think Matthew's on it.
Okay, good. So for what I've been up to, if it's time for that,
Yes.
um, having these Plutos crashing focused attention on this bit of infrastructure that I hadn't really thought about very hard for a while. Um, Back when we were trying to get stuff done on the big FPGA development boards, I had written up a bunch of procedures how to do it remotely, and they were a little friendlier to remote operation than the Pluto, which is kind of a bare bones implementation. Um, what I've been doing for new firmware updates for the Pluto is writing them to Flash, and rather than running them out of RAM, which is what Reese suggests, and also is why it's able to we say brick. It's not really bricking the Pluto, just causing it to be uncooperative at boot time, so you can't do much with it. Um, so I used the memory device mode, which is what Analog Devices recommends for general users, where you uh, plug in the Pluto, it automatically mounts as a mass storage device on your computer, and you can then just write a new FRM file uh, onto the device and then eject the device. And the device takes that as a sign to grab the Pluto.frm file and flash itself, which is great and easy and very convenient as long as the software is running. Um, if the software is not running because it crashed during the boot process, then that won't succeed. In fact, you'll never be able to get even the first step of it done because it doesn't mount as a mass storage device anymore. So now there's ways around that, of course, if you have all the access that you need. And not of all of those were clear in my head when I started a week ago, but I know a little bit more about them now. And the only way we were able to recover those Plutos that were in this inconvenient state. I'm trying to avoid saying bricked because it's not really the right word, um, although it's very easy to say. The only way I could recover those is by using the button. So the Pluto has, in addition to its two USB connectors, it has a little hidden button that you have to push with a paper clip or a toothpick or whatever you got that's long and skinny. And with the help of that, I was able to get into DFU mode, device firmware upgrade, which is a standard USB thing for this exact purpose, for updating firmware in a device. And I'm writing up a document that explains all those procedures so that next time when I've forgotten it all and this comes up again, it'll be right at my fingertips by reading the document. However, there's a problem. This was supposed to be a remote lab, and pushing push buttons is just not very remotable. It means we'd have to somebody here local next to the lab would have to get involved, and that would slow things down and be inconvenient. So it'd really be nice if there was a way to do this online. And there's supposed to be. There are a couple of things we can do. One thing that's missing right now is you'd expect for a standard Linux system that when you boot it, you'd see a bunch of stuff scroll by on the screen, starting with the U-boot and then going right into the boot procedure, possibly after a short delay if they think you're going to want to interrupt it. And then all the boot messages fly by and you get information about what's happening. And if something horrible happens, like what's happening to us, you'd find out exactly where in the procedure it was and maybe even get some clues as to what went wrong. And all that information is supposed to come out on a serial port, and it doesn't. I can't get it to work. I can't get it to come out on a serial port at all. I can't get it to be in an SSH session because you can't get the SSH session until the thing's booted. The serial port is supposed to be the fallback for that. Um, and I've read a bunch of web pages, both on the Analog Devices Wiki and the Analog Devices documentation and Engineer Zone threads and random searches of the internet. Even the Maya documentation has some extra clues about this. And I'm not entirely sure why I'm not seeing that. And there's one more thing I just discovered this morning that I'm going to try. I think there's something in the boot environment variables that tells it to be silent and not echo all this stuff to the console screen. And if I can figure out how to turn that off, then maybe I'll have the serial port again. And if I get the serial port, then maybe I can interrupt the during U-boot. And then from there, I can force it into DFU mode with just a simple command. And if none of that works, then the further fallback is to use the JTAG port. And the JTAG port works, but you have to use it through the Vivado tools that know how to talk to JTAG ports for this device. And they have limited sets of things. And like I can reset a processor, but I can't really reboot it. I can't force it into DFU mode as far as I can tell, except by loading some part of the firmware and restarting it and hoping that goes into DFU mode.
Right.
And that's possible. I'm sure there's a way to do that. I just haven't found it yet, and it's pretty well hidden.
Wow.
Once I put my finger on that, it'll be in the document too. I'll write it down, and we'll be able to recover. But even that has a limitation because the JTAG port is not brought out to the external connectors on the Pluto. It's an internal on the board, and it's not populated. So you have to put a connector on each Pluto. That's no big deal. And we've already done 3 of them so far. So they have connectors, but you still have to open up the box to get to the connector. And we only have one of the adapters that plugs in there. They're not the cheapest thing in the world. We could buy more if we wanted to have all the Plutos be remotely JTAGable. But we'd have to get those in order and get them in if we want to do that. In the meantime, we got the one that
Wow.
we can move around from Pluto to Pluto.
Yeah, we had this turned out to be something that was super useful back when we were doing the DVB-S2 encoder because the Pluto that was the target for that work, once we added the JTAG, then both Swato and Everest were able to use it and try some stuff out. Um, but
But it,
this is like advanced stuff. This is like a huge lessons learned. You I think you've probably given like a semester course in embedded like management or embedded design patterns. So I hope that it's okay to run your article in the newsletter and kind of
oh
get it
yeah,
out
sure.
there a little wider. That because this stuff, I think we found over the past week, just by listening and kind of paying attention to what you were battling, is there's a lot of recipes that don't work anymore that are old. So there's some stale
That's
recipes for
right. Yeah,
getting
that's a big
the
problem.
Pluto kind of unbricked, and then there's some like there's a whole arc. And those things have changed over time. So when you go and do a search and you think that you're going to find like the right answer, then you get a stale result. And if we can maybe summarize what works right now and what works for us, then I think that would be a real valuable thing to spread around.
Hello,
Yeah, go ahead, Evan.
Yeah, go
Evan
ahead.
here. Hi. I just want to mention as regards serial ports, I've done made a lot of connections, and it's all very tricky, you know. There's the parity and the stop bits and start bits and number of bits, and then the biggest problem I had that took a while to unravel was on Linux. There's dev ttacm 0 and dev the just plain tty0 s0,
Yeah,
and that has to do with whether there's a an engine on the modem or not. It's kind of tricky, so
yeah,
That's
might
true.
not be worth giving up just yet.
That one thing that's convenient and it's probably an accident is that the serial port that's built into the JTAG adapter is from a different manufacturer as a serial port that's built into the Pluto. So one of them shows up as TTY ACM 0 and the other one shows up as TTY USB 0. So
Oh,
it's always
you have to
able.
study that difference. That could be very much where it is.
yeah,
That I think I'm already on top of that. And even if
Ah,
you have multiple Plutos, then you get ACM one and USB one for the second Pluto. And it's not always clear which one is first and second, but you can sort that out, uh, even without physical access to the hardware, as it turns out. Um, but the getting the serial ports to work, I think, is that's we're beyond that. The problem is having the serial ports actually do something useful. And
ah.
it's up to the software that we hope to leave our hands mostly hands off of, um, provided by Analog Devices Reference Design, including a bunch of Linux magic that we'd rather not know about.
Well, what Evan's talking about would be really, I mean, he's exactly right. And if all the devices or if the hardware had the same manufacturer, then oh my goodness, it would be a lot worse.
Well, we've had that problem on the on the big Plutos. One of them has a four-port serial adapter, so it's USB 0, USB 1, USB 2, and USB 3, and which one gets assigned to which function actually changes depending on I don't know exactly what, but including the order of bring up.
Yeah.
So you have to sometimes look around and try a couple of different serial ports to find the one that responds.
Right.
Terrible. This is why USB exists, right? It's supposed to be smarter. So you get some negotiation. But all we've done with USB for serial ports is to hide old-fashioned serial port emulation under USB. And it's not the prettiest thing in the world.
Yeah. Well, thank you so much, Paul.
That,
This is
I,
deep geek sort of things. What do you need for the next week?
well, I don't know, maybe nothing unless we want to buy some more JTAG adapters. I'm not sure whether we do or not. I think Evan's
I will tell
familiar
you
with.
a funny story if I may, because I've grappled the serial on Galileo board and a number of boards, but I had an outboard project on a ESP32 board. It was a stamp, and it was just a simple serial connection. I'm very careful to build modules. I built an Arduino piggyback module so I could just run the serial wires right over, and it would not work. What I was supposed to do, and I was buy the matching programmer for this board. I didn't do that, but apparently that might have made it work. Who knows
Oh,
why?
okay.
Yeah, that's why we're using these relatively expensive JTAG port adapters, even though there's really nothing going on there except a standard serial port adapter and a level converter, because the hardware inside the Pluto runs on 1.8 volts. And
Right.
all the serial adapters are even 3.3 if they're not 5, if they're not RS-232.
Yeah, but Evan raises a good point. Sometimes you have to just go ahead and you have to sell out and get whatever they recommend. Like, don't fight the tool is a thing that we say a lot. Don't fight the tool. Just if the designers of a project use Ubuntu 20.02, then just use it. Don't try to force it to work on Windows. Like, it's the same basic idea. Just, don't fight the tool, don't fight the thing don't fight the adapter. That's good advice.
Yeah, it is. And I think Evan makes a good point that's going to affect my document. I'm going to have to add a section up front explaining about TTY ACM0 and TTY USB0 and how they relate to the Pluto, so
Yeah.
that the stuff that I think it is obvious because I'm familiar with it for a long time and I've seen it becomes obvious to people who read the document. Um, I don't think we have justification yet for buying more more JTAG adapters, but we may in the future. If I can't get a way to bring the Pluto back to life from this particular kind of failure using just the USB port that plugs right into Pluto, then we probably want to buy some more of those and have them all outfitted.
Okay. That's I think that's good by me. I'm pretty sure that it won't break the bank or anything. So go ahead and
No,
get it.
assuming they're available. Right now,
Yeah.
Plutos, for instance, are not available.
I
They're all
know.
back ordered. The next
Yeah.
batch of Plutos to appear at the distributors is sometime in December. It's a good thing that we were able to recover the Plutos, or we'd be wanting for development hardware.
Yeah. That would be challenging.
I think
Okay,
that's
yeah,
it for me.
oh, thank you. Thank you. That's a lot. So, deeply appreciated. And just let me know if you need anything, and we'll just keep whacking away at it like a tire iron to a dumpster fire. That's just how you get it done. All
Yeah.
right. So let's see. I have a report. So we've been asked, ORI has been asked to help with the FunCube Plus 2U CubeSat. This is a project that is pretty far forward in development from AMSAT United Kingdom, AMSAT UK. And if you're familiar with the FunCube and the FunCube dongle, this is a successful amateur radio satellite. So this is very exciting. And what they're envisioning for the FunCube Plus, their next, which will be, there's a launch that is scheduled. That's about all I can say, or in the process of being scheduled, working really hard on it. So this is a project that is definitely targeted for space. Everything's moving forward. So so not just a design for the background that we're working on in order to be ready for a launch, but a particular 2U satellite and a particular launch for FunCube Plus. The concept is a fast uplink and a slow downlink. And they call it a mode dynamic transponder or MDT. And this kind of leverages power conservation on the satellite. So it can receive fast uplinks and then meters out the communications back down from Leo um, at a slower rate. Okay, so right off the bat, we can model this in Python or MATLAB and kind of like play around with, gosh, how much storage would you need? Because I think right away you can sort of see that this is not instantaneous communications. This is not like a traditional transponder or FM repeater. that it is definitely sort of a digital mode thing that you blast up a message or, your communications, and then maybe sometime later, that it's then transmitted to anybody that is in the footprint. So that's kind of the idea. And there's lots of open questions about like exactly how fast, exactly how slow, how much storage do you need, uh, you know, what kind of ground station you need, how is it going to match up with the sort of traditional or historical FunCube modes. And that's kind of where we're at. Some work has already been done on this, and we are going to support that work, take it, understand it. I've been told there's block diagrams, and that there is some work done, and a sort of a sketch of a bill of materials. I haven't seen it yet. I'm gonna guess based on what I've heard so far that it's probably going to be the Lattice or ICE 40 based family. But a Xilinx chip could easily do this too. So I think that once we know more, and I will know more soon, that we'll be able to come up with a good solid, like, here's a domain modeling approach. Here's a Python notebook that lets you play around with uplink, downlink, what the impact is to storage, those sorts of things. So it's very exciting. And it's undoubted it's going to be a sort of this is a digital project. It's definitely FPGA project. And if you are interested in this sort of thing, please get in touch because we'll need a team of people to support the technical volunteers at AMSAT UK that are spearheading this. And we do need to start and move things forward as quickly as possible. It will all be done in the open. So this is an open source project and just kind of neat. So if you're interested in store and forward, you've always wanted to see the next generation of kind of store and forward amateur satellite digital modes, then this is an excellent opportunity to get involved or to follow along and to help us spread the word. So that's my report from the AMSAT UK thing. And then what we'll do is we'll set up a repository for the MDT, or the Mode Dynamic Transponder, and we'll go ahead and publish anything that we think might help with what we know so far. And as more information becomes available from the designer, from the technical volunteers at AMSAT UK, we'll just feed it right back into the repo. So that's the FPGA design, the MDT from AMSAT UK, and we are writing an article about the day that ORI folks spent at Dwingeloo, and this is a amateur and amateur satellite, and also amateur astronomy and citizen science facility in the Netherlands. And it has a really remarkable history, and almost was demolished about 11 years ago, but was renovated and restored, and is now a significant player in educational outreach for citizen science, for amateur astronomy, and for amateur radio. We were very fortunate recently to be able to spend a day there, and an article about all of the observations that happened during the day at Dwingeloo is in progress and nearly done. I'm going to send it right off to Thomas Telkamp, who was our host for the day, and have him and the other folks that hosted us review it for accuracy and anything that we missed, any other things that needed to be included. The article emphasizes kind of the value of amateur radio, amateur satellite service, and citizen science, amateur astronomy, and like maybe we should look for more of these sorts of sites. And when science kind of moves on and no longer needs infrastructure, that it can have a whole huge lifespan out there doing amazing things. So this was a really fantastic day. Was very fortunate, took lots of photos. So far the article is just words, and I'm going to try to put in some of the photos that me and the other ORI people took. And yeah, that's coming together really well. That'll be a good thing. One of the highlights of that particular day was being able to have a coordinated observation. So Dwingeloo was able to loop in Stockert, another similar site, and also the Allen Telescope Array, which is also very involved with citizen science and has a lot of opportunities for people to participate, and was able to put together an observation that incorporated three sites at once to do EME digital sort of a Earth Moon Earth bounce of a digital signal that then was used for research for Earth Venus Earth. So that was really neat to see. That's a cool step forward in experimenter stuff. So that's one of the things I've been up to is to try to record all of that. The presentation from Dwingeloo that was given at the recent AMSAT DL symposium, so AMSAT Germany symposium is already online and is really good. And it goes into the history of the site and the current work with Bockum at which is AMSAT DL's kind of home team, for lack of a better word. That's their big dish that they are most involved with. And so at AMSAT DL Symposium, then Thomas and a number of other folks really kind of like improved the infrastructure and the ability for Dwingeloo and Bockum to coordinate and to do this same sort of thing. So basically what you're doing is you're logging into the other site and you are directing their receiver equipment to pay attention to the same thing that you're paying attention to. So for instance, if you want to transmit to for EME, that you direct these other sites to like, hey, look at the moon, and then give me your receiver data. And as long as everybody has essentially the same or similar type of receiver data stream, then you can take these three or four sets of data and you can combine them mathematically and you can get really good results and you can then make a determination about the success of your particular design. So this was really nice to see. We did a lot of other fun things that day, like point the dish at this really cool ball in space. So if you're not aware, there's something called LCS-1. This is a spun aluminum radar target. It's just a silver ball. It's just a hollow metal ball at 2,500 kilometers, and it's been up there since 1965, and it lets you have a target in space, so a reflector essentially. And so we were able to use that in order to kind of ring out the dish. So that was really kind of fun because it's a LEO target, and watching this 25-meter antenna chase after a LEO thing was pretty cool. So anyway, that's coming out. We'll probably submit it to ARL for QST, and if they take a pass, then we'll just put it in our newsletter and on our website. So folks should be able to see it either way. All right, and I think that concludes everything on the agenda that I know about. That's what we've been up to over the past week. We do have two other articles in the queue at QEX for review. Our shortened HF antenna, the dumbbell project, we went ahead and wrote it up. There was a recent club that asked for a presentation, and they said, "Wow, this is good. You should write an article about all this work." So we did. So that's off to QEX. And also in QEX is an article about the choice of the synchronization word and the upgrades that we've done to make the synchronization word in opulent voice better. Like, why do you care about the mathematical properties of your sync word? Who cares? Don't you just match up to a digital sequence? And that article, so far, looking like it might get published. So we do have some other things going on. One of our volunteers wrote a nice letter in response to the IQ Signal Basics article with some critique about like, yeah, you didn't quite get it right, or you took too many shortcuts in the article. And that's fair. because the article was simplified and kind of broken down in a way that made it accessible. So maybe too accessible from the point of view of the volunteer. So what I've done is offered to the volunteer or I volunteers, like if you would like to send your letter to QEX as a critique of the article, then I can explain. I can provide at least a admission of yes, it's too simplified, or yes, this is what we were after, and you're right, but this is why. So we may move forward with that. So all of this is kind of in efforts to make all of this stuff more accessible to ordinary amateurs and to get people talking about things and get them exposed to really cool open source digital radio work. So yeah, we've had a pretty good couple of weeks here. The Halloween party where we had an open house. Thank you so much, Paul, for opening the remote lab and the lab you're sitting in and your kitchen and every part, all the other parts of your house, and the retro computing lab was a big deal. So thank you so much. This was a really big deal for ORI to have an event like that and to be able to show what it looks like when you log into this sort of stuff, what it looks like on the other side. So that was a real highlight of the year. I hope we were able to do some more open house events here in town and to invite folks over. So thank you so much for all of that. I know it's a lot of hours of work. All right, that's it for me. I think, let's see, Rick is here. And then, Evan's here. He has his hand raised, and I see Adrian. And welcome, Adrian. So go ahead, Evan.
Okay. Thanks so much. This RF bit banger that you've started me on has been fascinating for me. And that's why I'm back again today. Although I did want to briefly mention that my mentor who passed away, Al Katz, at the College of New Jersey, had a big Earth, Moon, Earth Bounce organization. It's an ARRL. I never attended it, but I don't know if that matters to you. Anyway, I just wanted to tell you what I'm up to with the board here. I've taken out the potentiometers and put in 3-pin plugs, the male pinouts, so that they can go to the potentiometers that will be mounted on the case. When I was shopping for a case, folding your own case is something I could get someone to help me with. But I have this clamshell. One fit kind of exactly, but it was a little too close. So this is very nice. And let's see, it's getting better. That mounts right in there like that. And then the top, I got the holes done rather nicely, close enough. After this goes on the top, the rest of the clamshell comes in and matches. So the coils are available and the screen comes through.
Oh, cool.
And as does right. So that took a while. I'm not that great a machinist, but I am getting more careful. It's interesting to say that. And I don't have a jack or a drill press or anything like that make it better. But what I do have in here, besides the potentiometers, which I've got to wire out with the right sort of cables, finding the right sort of cables is where I'm stuck right now. Although I do have the experimenter kind that plug into the breadboards.
Yeah.
All used to be those female versions. They're in the shop somewhere here. I've got to find them, and then that'll be done for now.
Wow,
you can always get
really
better,
cool.
but it can't get worse, right?
That
Yeah.
looks great. That's
And then
a big step forward.
this is a little cheapy audio amplifier. Well, it works very nicely off of Amazon from China, and that's used to take the output stage, the output jack, and put it into big speakers. And when I did that, I was able to use the device pretty well and even make a contact.
Wow, right on.
But after holding together all the wires from even these two boards and everything that needs to be attached, I said, no way, I can't let that go on. So that happened all about 4 months ago, and now maybe I'm going to close the corner and get back to testing the radio and making some updates, trying the wiring I had done myself before the board came in. Because if you remember, the board you didn't see the detail on the board for a while. But I have a goal of going back to the Ham Fest as a vendor. Um, Maybe I'll have something by next March. That's when the Cherryville Ham Fest is in Flemington, in Clinton, New Jersey.
Okay, yeah, let us know any places that you might want to go, and we'll try to get the word out. And thank you so much. This is so cool.
Thank you.
Uh, Evan, Evan, this is Adrian. I'm kind of a newbie here, and I was just wondering if you could explain to me what I assume you said you made a contact, so it must be a transmitter. But I was wondering if you could tell a little bit more about it.
This is a very wonderful radio that Open Research Institute offers. It uses a balance modulator to basically be an HF radio. Yes, HF transceiver, correct.
Oh, okay.
Uh, the,
So it's down in the what, like 40-meter ham band, that sort of thing?
well, right now I do have it set up for 40 meters, and what happens is the signal comes in from the antenna. It's filtered for 40 meters by this daughter board. That's a custom board that Open Research Institute provides with the kit, and then it goes into a balance modulator. So the balance modulator essentially, I don't know exactly how the calculations for it work. I'd like to learn that, but although my math is good, my physics is not.
So
So
Yeah, you can swap out the little daughter board for any of the HF bands. So
well,
that
you do want to
comes with
filter
all of
them
them.
apparently.
Yes, yeah, you do. You want a filter. So it's a filter, you swap the filters out, and then it's a kit. All of the surface mount parts are done for you. So because surface mount soldering is kind of a pain in the butt.
oh
But
yeah,
you put in all of the through hole and all the cool parts, and you wind the toroids, and you make your filter
cool.
boards. So you swap out the filter boards for which band you want to use, and there's 3 extra boards in case you want to do some custom work for bands that we didn't think of that are not the traditional ham bands. So it's just a low power HF transceiver kit that gets you up and running with a modern amplifier, and it's got a built-in digital mode called SCAMP, which uses the same forward error correction as FT8. So it uses LDPC style coding to get you the similar performance, but instead of having the highly structured back and forth contest mode, then you can chat keyboard to keyboard. You can plug in a regular keyboard directly to this radio and then do keyboard modes.
I see. So there's no audio modulation. It's all digital, right?
It is a digital kit.
What
For
happens is a frequency generator puts out 7.2 megahertz or whatever your station's going to be, and the balance modulator converts right down to audio. At which point, it's audio output after that, all analog audio output.
True.
Okay,
Yeah,
I mean,
if you're looking to do voice in a pinch, you could probably force voice through it, but it's designed for CW. It'll as a CW encoder decoder built in, and the
okay,
scan digital mode. So not
oh, that's
necessarily a
neat.
voice-based kit.
Uh,
Well, actually, it
So
has an SSB modulator capability based
that's what I
on
was going to ask. Because yeah, with the
tricking the
balance modulator,
FSK.
that's what I was going to ask. Yeah,
Yeah, it's based on tricking the
cool.
FSK modulator into making something resembling single sideband. It's tagged experimental, but
I see.
Right.
in there.
because
Yeah, that's
apparently a balance modulator has both sidebands on it, right?
Yeah.
Oh
yeah,
wow.
yeah. So you can do double sideband. Cool.
Great.
So what's the approximate power output? Just a few watts?
I have no idea. I don't even know how to measure that.
Yeah.
Yeah, it makes
Oh well, yeah,
like two or
little
three
power meter.
watts,
Yeah.
um,
It's,
2 or 3 watts. Yeah,
and
yeah.
fading out as you get to the higher frequency HF bands.
yeah. It's close to
That's cool.
5 lower down. So 5 watts or lower is QRP, and so it will give you
Yeah,
pretty much close to 5 at the lower, but at the higher, it's closer to 3. So a couple of watts.
cool.
If you wanted to make it
Yeah,
higher power, you need an amplifier, but it's designed as a
it's
low power HF kit.
Little QRP system. Fantastic. Okay, great. Thanks for showing it.
Oh, sure. Yeah, if you want one, we have them on our eBay store. We sell them at cost and
Uh, Unfortunately, I only have technician license, so I can't get down there in the HF bands.
oh, well, you
I
need
think,
to upgrade. And
oh, I'm not
you
interested.
can That's
To me, anything below 6 meters is DC.
right. Or IF band, right? Yeah, I get it.
Yeah,
What?
it's like, okay, wow. So it bounces off the ionosphere. Whoopee.
The RF bit banger also has a pretty good receiver in it. You don't need a license for that.
Oh no. Well, I got plenty of receivers. I got plenty of
I
those
think most
guys.
people who get the RF bit banger already have better radios.
Yeah.
It's just for play.
I even have
It's a
some
fun
old
thing to build.
ARC-5 World War II transmitters
Oh my
sitting
gosh.
around.
I
I
have
actually
one,
that
I
was
have one too, an Arc 5. We need to talk because
yeah.
I don't know if mine works at all and I'm not sure how to
Well,
get it.
mine's not on the ham bands, though. It's the only reason the ham band ones, capable ones, just went really fast. So I got two or three of those guys, and just fascinated. I actually, when I was a kid, that was the first thing I ever fired up and sent a
Oh wow.
transmitted sort of bootleg sort of pirate station out to a friend of mine about a couple of miles away, and to his Drake shortwave receiver, and did some cathode modulation on the 1625 power amps that are the power amplifiers. Are a couple of parallel 1625 tubes, and just modified to do cathode modulation on it.
Wow.
Barely squeaked out, maybe 2 or 3 miles away
Wow.
with a power supply that I had. That was the very first thing that I ever transmitted on. But
Okay,
yeah,
well, we need to
cool.
talk more and maybe you need to be interviewed because that is really, really cool. So
I'm too
we
old.
need to talk more.
I'm too old.
No, you're not. Stop that. All right. Well, hey, Rick is here, and Rick, you have the floor to share anything you'd like.
Well, they they received all of the precision time and frequency equipment from San Diego.
Oh, good.
That was a big deal. The president of the company and his wife, the owner of the company, showed up here last week. I spent 3 days with Art and one day with his wife, and we we had a wonderful time. And he dropped off a rack of equipment, including the rubidium HP 5065A, and we brought them all into the house to warm them up before I turned them on and begin the process of calibrating and getting them back up and running, and then they will they will be the cornerstone of the Artemis 2 project for tracking the manned spaceflight mission to the moon. So I was very pleased that all that equipment showed up and appears to be in one piece.
Right on. Hey, you want to tell people a little bit more about why time is important?
Well, because NASA has invited us to participate with a few other sites around the country in tracking the manned spaceflight mission using Doppler techniques so that we will receive their telemetry, but we will not be able to unwrap it because they consider that secret. But we'll be able to receive the telemetry carrier and track the Doppler shift of the carrier at what was that frequency? I can't remember now. It's in the neighborhood of 2 gigahertz. Um, and so if a number of sites track the Doppler shift of the carrier, the theory is we'll be able to tell in real time the position of the mission as it approaches and circles the moon for 4 days and then heads back to Earth. The total mission is, I think, 6 days, but it'll be circling the moon for 4. And so to measure Doppler very precisely, everyone needs a not only an accurate clock, but they all need to be pretty much synchronized to each other. So the system I have in my lab is identical to the system that was donated. And so it should be able to synchronize to GPS and have a frequency error of approximately 1 to 2 parts in 10 to the minus 12. And that should be sufficient, we think, for this mission.
Yeah, so it's not just a question of being precise, like to have a low resolution on your time, but also to be lined up with or synchronized with other observations.
Yes, yes, absolutely. So we use GPS time to calibrate the oscillator, and then we will not steer it during the mission. Rather, we will measure the offset that remains in the oscillator during the mission, and that way that way there will be no steering artifacts, which happen with GPS DOs when they try to steer in real time. There are ionospheric effects that sort of mess up the frequency of the reference oscillator. So we'll calibrate it to GPS, then let it free run for 4 days but measure the errors as a function of GPS measurements during those 4 days, then remove that error term from the Doppler data as we're reporting it. So it's a fairly complex process, but it's the same process we use with NASA's VLBI and VGOS systems for radio astronomy. So I'm fairly familiar with how it's done, and I'm pretty excited because we should not have any problem receiving the signal because it's so close. I mean, it's being broadcast from the neighborhood of the moon, and we routinely do much weaker signals than that. So our main purpose or process here is to get this precision time and frequency system set up, and then use that to as the input to our software-defined radio, which will be a EDIS B210 for receiving the carrier. So everything is synchronized to this precision oscillator, and we're really excited about participating in something that's not just science. It is science, but it also matters. There's real people out there.
That's right. What's for people that aren't really familiar with this attempt? Tell them the time frame.
The mission doesn't have an exact time frame, but we were told it'll happen around April of next year.
Yeah, so not years away, like less than a year away. And I think that already we've seen outreach, you know, uh, the desire to include citizen science and amateur stations, capable amateur stations, to kind of get involved in this
Yes.
project. So this is coming up, you know, so not that long in the future.
So I'm not sure how they're going to incorporate. There appear to be like two different categories of stations. The stations uh, that are being asked by NASA and their subcontractor, Lockheed Martin, specifically to be a part of this program. Those are stations with substantial capabilities, like we have a 60-foot dish. And then there seems to be a another group outside of that, which is the general purpose amateur uh, involvement of just people from like HAMSI and that kind of community, uh, where we can get many, many more stations, uh, but maybe with 10-foot dishes or 6-foot dishes, that kind of thing. And maybe they don't have quite as sophisticated a precision oscillator for their system, but they can still provide important input. I'm not sure how they're arranging all of that or who's managing the citizen science half. I submitted the they haven't actually put out like contract requests or any of that. They put out a request for information from specific stations with large antennas, and they've asked us to provide not a proposal, but a response to the request for information, which I wrote up and sent in about a week or 10 days ago.
Yeah, right on. Like, is there so at Deep Space Exploration Society, do you have a project page or a landing site or
You know, I don't, and I will. The reason I don't is, well, I spent all day yesterday in the hospital waiting room with the wife of a good friend who had open heart surgery again. Uh, and I spent all day Sunday uh, with a whole team of amateur radio people, wonderful, wonderful volunteers. And we finally pushed all the runs of LMR 600 and rotor cables through the 2-inch PVC pipes that I had buried 6 months ago for that purpose.
I got it. Okay,
It
yeah, other
takes
stuff
a
has come up.
minimum, it takes a minimum of 6 people to do that. And
Yeah.
getting 6 volunteers together on the same day at the same time, oh my God. So I'm going to write that page. The page will be up. I'll let you know when it's up. I'll just
Okay,
have,
cool. Yeah,
I,
it'd be good to be able to point people to like here's an accessible organization doing this
well,
and it would allow people to kind of learn and to get ramped up into it.
oh, absolutely. The pages I did put up are thanks in large part to you. Um, is we did get full board approval, and the pages are up describing our formal policy for everything we do as work product, not purchase product, but work product like this Artemis activity will be open source hardware and software. And we have a couple of pages on that subject uh, on the About page on DSES. So thank you, Michelle, for helping me with that.
You're very welcome. Happy to be able to do it. And
Okay.
Say,
congratulations.
Rick,
It's a big step.
Yes, yes, sir.
Rick, I have a quick question. Are you familiar with the Event Horizon Telescope work?
Yes. As a matter of
What?
fact, the head scientist of that is a friend of mine.
Great. So did they use also rubidium clocks, or did they use hydrogen masers more accurate for that observation?
Uh, with the sites that I sell my products to, which are pretty much identical to what I'm talking about, are hydrogen masers with in many cases uh, rubidium backups, but not any rubidiums. The modern rubidiums that you can buy now are not anywhere near as good as as the HP 5065 series was. And that's unfortunate. Nobody's building rubidiums that good anymore. So I've been collecting the last generation HP 5065s that have the good crystal oscillator in them. Um, that um, and that's what we're going to be using for this Artemis project.
Okay, thanks. Yeah, I was just curious if they required better accuracy than just rubidium for being able to run all those different signals through the correlators and get those
Yeah,
images.
yeah.
Okay, great, thanks.
They use two types of hydrogen masers, the original ones, which are absolutely insanely expensive to keep running, but they're still using them in at least two of the sites I know of. And then you can actually buy one from Microchip now for 400,000 or 500,000, and they're half the size, easier to maintain, and have
Only?
built-in test equipment. And that's all fine and dandy if you've got half a mil to spend on it. If you
Sure.
in between, you can buy cesiums, but none of the sites use cesiums because the high precision cesiums, the bulbs run out of cesium in 5 years and are unobtainium. No one makes new bulbs. So yeah, it's 5065A rubidiums or hydrogen masers. That's pretty much where it is. There are better oscillators out there, but they're not good for field use yet. They're still science experiments, like rubidium fountains and mercury fountains and so forth.
Sure. So those cesium cells, I thought I'd read where some people have actually been able to like I don't know, cook them in some ways and then sort of restore functionality to them. Is that
No,
something you've heard of?
no. You can do that with rubidium cells like the
Oh, maybe I meant
5065s.
rubidium. Yeah. Okay.
Yeah.
Like the ones that were being sold that were used like I don't know in cell towers or something at one time.
Uh, oh, those are, I have some of those also. Those were the ones that were used in cell towers and crypto gear are pretty much the same, and they're small cubes.
Yeah, I
And
have a couple of those. Yeah. Uh-huh.
yeah, they're okay, but they're not 5065As by any means. Where
Sure.
are you? You silly dog.
Sorry.
What is going on?
Okay. Well, yeah. Well, thanks for the info. I appreciate that.
Yeah.
Fascinated by that EHT stuff. That was really some tour de force on that.
Yeah, my friend Shep Dolman, uh, I met him up at Haystack one year when he sat in on one of my presentations, and I didn't know who the hell he was. He wasn't famous back then. He was just a scientist in a back room. And we started talking, and he told me that he was going to do this thing to look at black holes, and I had the same uh, odd reaction that any engineer would have. You can't look at a black hole. That's ridiculous. And of course, he explained that I was wrong, that you can look at the event horizon of a black hole. And so we talked for hours that day, and
Yeah.
he
Wow.
became uh, uh, a very special person and that I had learned a lot from.
Fantastic.
Very good. All right. Any other comments or questions or anything that anybody wants to share before we close for the day?
I've got a couple of things.
Yeah, go ahead.
Um, I was looking at a teardown of a brand new model of oscilloscope from Regal.
Oh, yeah, I saw that one.
Yeah.
On YouTube.
Yep, on YouTube. That's where all the good stuff is.
Yeah.
The interesting thing I wanted to bring up about this oscilloscope, aside from the fact that it makes the one we have in the lab now one more generation out of date, is that it's based on an FPGA, and they used to use Xilinx Artix 7 FPGAs, and now they're using a Chinese clone of a Xilinx Artix 7 FPGA, drop in one for one direct replacement. And the rumor is, according to the forum on the EV blog forum, that they've got cooperation from Xilinx to do this.
Oh,
Or
sure they did.
it's uh, sort of a second source arrangement kind of thing because they can make them in China and sell them to defense customers in China, which the United States manufacturers can't do, not
Oh,
at the moment. So both companies actually come out ahead on this, and it's probably part of the recipe for hitting an amazingly good price point together with their custom silicon for the actual oscilloscope parts. So that's pretty cool.
Yeah, I'm thinking maybe you can buy $20 parts again.
Yeah, if you're Chinese
Yeah.
or if you can smuggle them in. Um, this is
wow.
Arctic 7 is not the kind of device we're using, but it's, maybe someday there'll be zinc clones or even ultra scale clones from these guys if they
No,
are
it's in
successful.
the ballpark. That's close. Those are parts that are pretty close to what we're using. So
Yeah. So
that's interesting. I guess I'm not too surprised that this would happen, but wow. Okay.
yeah, not sure how reliable this rumor is on the blog post, but or the forum post, but it's an interesting thing if it did happen.
Yeah.
That the teardown shows that very clearly shows the top of this device, and it's got Regal branding on it, not uh, what's the name of the company? Fudan Microelectronics.
Right.
Um, so maybe they're trying to be a little
Yeah.
under the radar about using this Chinese clone chip.
Wow.
Well, we used to do that at Harris Corporation back when I was a kid. We would get certain parts that for our HF secure voice radios, and those parts were going to be sold to country B who
Yeah.
hated country A, but they were manufactured only in country A. So we would sand off the tops of the parts and spray on Harris logos.
Badge engineering.
Yep. Yep.
And you can only imagine what countries they are because they're in the Middle East.
Right.
And
Wow.
this is back in like the
Yeah.
late 70s.
Wow. That's enough for a book right there.
You betcha. Maybe even some spy novels.
Wow. Oh my
Yeah.
gosh. Okay.
Well,
Well,
actually, we did have some of that. One of my technicians was over there, and then the war broke out, and he got captured, and we had to pay money to get him out.
oh my gosh.
Yikes.
Oh yeah, I told you, Michelle, I got stories.
You do. No, I told you. I've already told you that you need to write a book and that I'm willing
No,
to
so,
advance the money. Like you take my money.
I'm
Was
a,
it was he one
some,
of was he one of the ones that got rescued by Ross Perot?
well, I can't say anymore because
Oh, you'd have to kill me then.
some of those guys who wrote books are being investigated now for not asking permission.
Because Ross Perot sent out a rescue uh,
That's
mission
right.
to get his people out of I guess country A.
Yeah.
Oh no,
And I won't say
that
any
was
more. I don't want to get in trouble.
that was country C.
Oh,
Country
the country
C.
C. Oh, okay.
Very good.
Sorry. The
Oh my
the
gosh.
other the other corner of the Middle East. All right.
Oh
Okay.
God, yes. There's so many little countries there.
Now, come on, Rick, we know that you need some excitement in your life and that an investigation.
Oh, I'd love to be investigated.
There's no such thing as bad publicity after all.
All
Now,
right. Well, we
one of the
best
things I
not get
want
him
to
into any more trouble. Is there anything else you said you had several things?
I've got some show and tell here.
Oh, go ahead.
So this item here is just
Cool.
another one of those USB adapters, right? That says USB here and 5 volt serial up here. Uh, this one is interesting because it's based on a Raspberry Pi Pico chip, the RP2040. But what's really
Ooh.
cool about it, it's got a display.
Oh,
Oh my
wow.
It
gosh.
shows the data as it goes by and can capture it at fast serial port speeds without dropping any bits. Just came out off crowd supply from L Camera Labs or something like that. Um, it's
Neat.
so new that they've shipped the hardware, but they haven't shipped the documentation yet. So I haven't actually plugged it in except to the USB. It's supposed to handle 3.3 and 5 volts, 75 to 115, 200 baud, auto botting, completely auto botting. Um, it's pretty cool and open source hardware and software.
Wow, right on. And you said is it term driver? Is that a good search?
Yeah, Term Driver 2 is actually what it is, and you'll find it on Crowd Supply. And there's also the maker who's, guy in a garage kind of maker has a website as well.
Right
I
on.
gotta get me one of those.
Wow. Yeah, the
And what
display
is
looks really
what's it
bright.
for? Is it die squared C or the JTAG?
Well, that's just the serial port adapter, async
Oh
serial.
yeah, okay.
And it comes in the cutest little box.
He has a
Oh my gosh,
he
that
did
is
he
so
did a whole
cute.
he has a newsletter, and he talked about 3D printing a I don't remember what he called it, but basically the boxes come all flat, and so he built 3D printed a
Yeah, a little
thing that he
folding
pushes
manual
the
for the
box down
box.
on, and it folds it open to put the stuff in.
Oh my gosh. Okay, overachiever.
Jeez.
It's not the cheapest serial adapter, but it's coolest because of the
It is
display.
the coolest. That is really neat. Oh my gosh.
It looks like an OLED, but it's not. It's just a really bright LCD,
Oh, okay.
That's
Wow.
not an OLED.
not an OLED.
Huh. Okay.
Wow. Man. Can
Okay,
I
now
ask a
I'm done.
question, Paul?
Yeah.
Can I ask a question? I missed the very beginning of the presentation, but how are you coming along with those poor Plutos that last time were bricked?
Oh
Just
yeah.
curious.
They have been
Tell them the good
released.
news.
They've
It's
been
good
released from
news.
the injured reserve and are now
Wonderful,
playing
wonderful.
again. Um,
Great,
was it-
great news.
we were able to unbrick them using the button method, although that didn't seem to
Oh,
work the first time I tried it. It worked later after
wow.
we'd
No,
Okay.
fiddled with some other
no, it
stuff.
did. It's not that it didn't work the first time you tried it. The first like 7 times you tried it, it didn't work until I think
Whoa.
they were turned off and left off overnight. And my completely uneducated theory is that with superstitions is that leaving them off for an extended amount of time and not pestering them made it to where the button method would just simply work the next time that they were woken up. So they just needed a good little rest.
Yeah, I think my best theory actually is that it did work the first time. I just didn't know because I made a mistake in trying to use the DFU mode. Um, it's weird to me anyway. It seems weird, but the DFU util program that actually talks to a device in DFU mode, it has to be run with privileges, even though it's only modifying an external device. So if you don't
Hmm.
either run sudo or have um, the right
Oh,
UDEV rules in your
God.
system, then it doesn't say I don't have permission. It just gives wrong answers. And there is a code, one of those all caps error codes like you get from with or no results, except it's a non-standard one,
Oh, man.
and it has the word access in it. And that's supposed to be your clue that you didn't have permission to use the device that way.
I just love Linux.
Yeah.
It's so
Isn't it
cryptic.
fun?
It's so great.
Yeah, you have to be
Well,
a mind reader to use Linux.
any networking problem, if you just kind of like sit back and look wise and go, oh, DNS.
It helps to have a beard.
It helps to have a beard. Yes, you have to stroke your beard and you go, oh, DNS problem. Yeah, and you're probably going to be right. And when it comes to like an individual computer problem, if you just lean back and go, sounds like permissions, then you're probably going to be right. And oh my God, shocking. Turned out to be permissions.
Yep.
So anyway, that's my advice for everyone today is you can blame DNS or permissions and like that's your 90% rule.
I was kind of hoping Everest would show up and tell me what was wrong with with the Plutos, and that they don't ever spew out the boot output to me on the serial port. They're supposed to, according to everything I've read, but somehow mine are not doing that. I can't get it to generate that output at all on the serial port.
Yeah, that's
So
been
Hmm.
one more
helpful
thing to
for
try.
us on the larger dev boards on the ZC 706 and the ZCU 102 and the other ones
Yeah,
that
that
we've
works
had.
there.
Yeah,
If
it
you had the
does.
right ports.
Yeah, if you get if that USB 0, 1, 2, 3 thing, if you get it sorted out and you're actually connected to the serial port, you get a ton of good information and you're able to pause and get in there with U-boot to like stop it to then you have lower level access. And with the Pluto, it doesn't seem to give you any of that. That's a little trickier.
I have seen Plutos give that information. It's possible. There's just something wrong with the configuration of mine, I think. And I have a clue that I might know what it is, but I haven't tried it yet.
Well, maybe another thing for the article.
Yep.
No, I forgot to tell you, my Yig oscillators to try to repair all these spectrum analyzers.
Oh yeah.
Um, I I have this one is the one that failed. Um, it became noisy. Then I have one that I burned up. Thank you very much. They're worth 500 to 1,000 apiece. Uh, Another one didn't work when I ordered it on eBay. It was dead on arrival. And finally, on the spectrum analyzer, I have a perfectly working Yig. So I should be able to reassemble my spectrum analyzer any day now.
Right on. Very good. Outstanding. That's
Wow.
been an odyssey.
Then, if I'm smart, I will sell it on eBay and buy one of those Rigel or Signalent because they have features that were never even thought of when HP designed these spectrum analyzers.
Okay, yes, this is the wisdom. Okay, good luck with that.
Wow.
Very good.
What's the bandwidth on that spectrum analyzer?
6.5 gigahertz with tracking generator and noise
Uh,
figure option.
Too bad it doesn't go up to 8. That's bad.
Almost none of them go up to 8. If they're above 6, then they go to like 10
Well,
or 12 or something.
yeah,
Right.
They
Yeah.
get real
Yeah.
expensive.
yeah.
Yeah. You need that 8 when you want to look for Voyager.
And well, I have other equipment here for that.
Very good.
Like
All
what?
right. Yeah,
Oh,
yeah, that's gonna be
one of those
your
mini,
target
the
for
mini,
DSES, right?
yeah. Well, I have the mini spectrum analyzer. What do you call it? The
The little VNAs, nano
Yeah,
VNAs.
well, I have a mini VNA and separately a mini spectrum analyzer that
Uh-huh.
go, and they're not the $50 models, they're the $350 models that
Uh-huh.
have that go up higher in frequency. They're really nice.
They go up through 8 gigahertz.
I don't remember.
Oh, because I've got one of the little nano VNAs, but it drops out around 6, and
Oh,
that's just kind of
the
below.
VNA does. I don't remember. Some of them are better than others in that regard.
Yeah,
We should get together and have
I
a meeting
I
that's
really
just on all of this, like the Nano VNA suite. Like we should get together and have a show and tell
Sure.
like meetup about this sort of stuff because there's lots of choices and there's some it's really interesting stuff that you can do with it and they're really not horribly expensive. We should have like a little meetup and a show and tell night.
Yeah.
I had kind of a bad experience out of the stupid eBay. Also, kind of like you, Rick. I got one of those little nano VNAs, and it arrived with the touch screen dead DOA, and so it works fine, And of course, you can do the plug-in with the computer software, but the touch screen is dead on it. So I had to go get a second nano VNA to get one that I could use portable with the touch screen working. So, and those touch screens, looked everywhere. I don't think you can get those individually to replace just the touch screen if that's not working. Oh well.
So, depending on who you buy them from, you can send them back. I buy them from, what is it, Ham Geek and
Yeah.
not eBay. And Ham
Yeah, I
Geek, I
forgot where I
think
got it from.
you can send them
Yeah.
back.
Well, the problem was that I waited too long to use it. So by the time I got around to firing it up and using it and realized that it was DOA on the touch screen, it was way past the return date. So I
Oh,
got stuck with it. Yeah,
so
a
my,
lesson to be learned.
yeah, I just looked it up. Both my spectrum analyzer and the Nano VNA that I have are both 6 gigahertz.
Yeah, I haven't found one that goes up beyond 6. At least maybe not anything handheld and affordable anyway.
Well, you just
Uh,
build a front end for it, that's all.
Oh, is that
really
all?
for Well, for a spectrum analyzer, I'm sure you can just put a mixer up in front, but you can't do that for a VNA, can you?
What's the
No, not
effort?
for a
Yeah.
VNA.
Yeah, that's what I thought. Yeah, that's what I look.
Yeah.
Yeah, that's what I thought.
Oh boy.
Yeah, spectrum analyzer, boy, you can just put
Yeah, just
like a
whip
little
it
converter
together,
in front of it.
Just
Yeah,
pull stuff out of your junk box, right?
yeah. I mean, I do. I mixers and whatnot, and I've got an 8 gigahertz GPS disciplined oscillator. So you just throw a mixer together, and yeah, you feed a signal into it, and there's your spectrum analyzer. But just do a frequency conversion in your head.
So what you do is you can make uh, it's not a full VNA, but it's close. You take the spectrum analyzer, put a mixer in front of it, and then put one of these directional couplers in, and
Oh yeah,
you can
sure.
derive uh, you can derive everything you need if you're like testing antennas and stuff. Not so much for
That's the main
filters,
thing. Yeah.
but it'll do S11 just fine with directional couplers. I've got them for all frequencies.
Oh yeah. Well, those are sometimes hard to get too. Yeah, I'd love to
Oh,
put what I put. Yeah, I want to do some cavity filters and stuff, and for 8, and it's just kind of hard to do that without some equipment for testing. Oh
yeah.
well.
Well,
Uh,
if you want cavity filters, I got plenty of those too.
well, for 8 gigahertz.
No, because nothing I did in the past was 8 gigahertz.
Yeah,
So what we're
that's the rub.
doing what we're doing now is we just tell Alex, build me one.
Oh God, yeah, Alex, man, the guy has access to all that stuff. I mean,
Well,
that must be great.
he's got the right kind of machine shop for building these size and precision equipment in his
It
garage.
gets small. Yeah.
So
Wow.
you got to have the right kinds of sheet metal benders and stuff, and he's got all of it. And so we just tell him, oh, we need a filter that does this, and this, and within a couple of days, he's built it.
Well, if you got access to that, I was thinking of just the old copper pipe cap type, old ARL type of filters, that type
Yeah,
of thing.
yeah. Well, he builds those too.
Yeah, those are cheap and affordable, but you still
Oh,
have some
but
set
it's
some equipment
nice.
to tune them up.
You got to
Awesome.
be able to tune them. That's it.
Yeah, exactly. My point. That's the point. Yeah,
So the
great.
other option is to go to the ham fest where Rody, who's the ham, brings his technician and their 10 or $100,000 Rody and Schwartz,
Yeah.
100 gigahertz VNA, and he lets you sit there and play all day long. He
Not
does
bad.
Well,
it at
that's
Microwave Update and all those kind of conferences.
Well,
that's pretty generous.
let's try to put together we'll try to put together like a little online open house, and people can swap stories and show all the, because there's like just tons of these really amazing little items. Maybe I'll try to put something together.
We should design an ORI 15 gigahertz front end for the mini spectrum analyzer or tiny spectrum analyzer.
Yeah, if it can
15
handle.
gigahertz.
It can handle
Sure, why not?
baseband, up to
Yeah.
15.
I have this sort of a boat anchor. It's a tunable magnetron, okay, and it's up there on 16 gigahertz. I mean, the thing I think it came out of, I don't know, some kind of a tail radar gun for B-52s or something, and it's actually a tunable magnetron. It's got a coupler at the top, and you twist it, and it dial moves around. And you look at the specs on that thing, and I think it's like 100 kilowatt output or something pulses.
Oh yeah.
And I mean, it's just like I originally got it because I thought, well, it doesn't work. At least I have the magnets for it, But it's a real gem.
When I was in the Army, I worked on the Nike Hercules missile system, and we had a 8 million watt transmitter whose driver was a tunable magnetron, and that fed an amplitron, and then you had another magnetron and amplitron, and you put them into a diplexer, and whammo, 8 million watts.
Wow. Yeah, that's something.
And that's fine and dandy until I stuck my hand where it didn't belong. But
Oh, wow.
that's a story for another day. Okay, I've got to run. I've got a doctor's appointment coming up.
Yeah, we got driving chores and got to get back to the lab. But thank you, everybody. This was great, and we'll do it again soon, and maybe have a little open house where we can share about all these really fun devices. There's a whole big class here, and might be some things that we can do to improve them and make them useful for what we're doing. We certainly have used them from time to time and gotten some good results. The article that we just submitted about the shortened HF antenna, we used some of these, vector network controller type, little antenna analyzers to confirm that we weren't way off base with the results that we were expecting. So they're super useful. All right, everybody. Thanks so much, and see you again really soon.
Okay. Bye-bye. Take care.
Take care, guys. Bye-bye.